And we are streaming. Okay. Not the most delightful of intros, but you know, it's an intro. Okay, so where are we at from yesterday? Yesterday, we got a simple compiler implemented for our stack based language. Nothing super crazy. We don't have loops implemented yet. This is just the concept we came up with towards the end of the stream, or how we roughly want loops to work. Um, yeah, it's essentially just going to be a go-to, much like every other block-based conditional or jumping thing is. But instead of it being something that happens always unless a condition's met, and then it breaks out, it's something you have to um, invoke happening again. Otherwise, it just ends. We'll see. We'll see how this goes. I'm sure this is probably something that's been in another language at some point already. But for now, I think we should get to trying to implement this, which will be fun, hopefully. So, the only thing we're missing, I think, would just be the loop and again keywords. So, yeah, let's do that. Not leap. Not quite the. What I'm looking for. Just did it again because I'm a Norman. To be fair, I don't think this is sorted, is it? No, it was not sorted. Might be worth doing it. And this one goes at the end because it's trying to be fancy. Anyway, so that should get picked up. Oh, and the again keyword. Yes, 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 yes. Again is definitely going to be going at the top. Easy enough. Okay. Now we just need to handle these two in level intermediate representation. Let's do a not implemented yet for now. In terms of the loop's going to act pretty much the same as if, in that it just sets up a node that can be used to backpatch anything from the again and the end, much like integer, sorry, not integer, end works already. But instead of just checking for ifs, we're also going to be properly doing a switch over this and then setting stuff as expected. Say we have a loop. So struct will have the begin and the end essentially of our loop. So do those. I should probably call these then index, end index, and such, just so we know it's an index, not just a random U size. Yeah, maybe at some point. As I said, this is going to be the same as if. We're just going to be setting up a loop instead. So begin and end. And then in our end here, we want to check what we have and then do stuff depending on that. Let's just switch this. So if you're an if, we want to grab the if and then set the end to the end node index. If you're a loop, we'll set the loop end index. And if you're something else, then something's gone wrong here. So this would be I think we have where is it? Yeah, yeah, then without if and then end without if, and this would be end without if or loop, I suppose. Maybe not. Just do this ourselves then. or and that will probably break in a few places, but we'll fix that. For this, we will. Okay, so this is not really the right name. Conditional stack. This would be more of a block stack or something. I'm not entirely sure. Just do it the old-fashioned way since nothing wants to work at the moment. Probably because there's an error here. Okay, so if we see these and it isn't a... So here, yeah, we've checked to make sure that there is something in the block stack. If there's nothing in the block stack, this should be valid. This should be unreachable. If we reach else here, then something has gone wrong because we have pushed something to the block stack that shouldn't be in the block stack in terms of an index. So we can keep track of that nicely. Anyway, that should handle that. Where to next? Let's handle all possibilities. Yes, 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 indeed. We need to handle... Oh, yes, we're also not dealing with a gain. So a gain is going to work kind of like then, I suppose. Oh, yeah, then is only going to work on ifs. Which we want to check. So we'll say to do a check that the node is an if. Because here we're not just using whatever's inside the block. We're expecting specifically an if in the block, not an end. Oh, that's a good point as well. So end again doesn't want to interfere with ifs. Again only wants to care about loops. Maybe it's worth having two separate stacks of these then. So we have our if stack and we have our loop stack. The only problem here is if we have these separate, we now care about, in the end, we care about both of these. So either we separate out the two ends to do different types of end, which isn't the best, or we can keep our block stack and have some kind of block, you know. And here we can do our if block, which is just a usize, or our loop block, which is also just a usize. And now when we do stuff with our block, we are, where are we at? So yeah, when we push our if, we're not just pushing a node index if, we're pushing an, so there we go, an if, with the node index, and then similarly we're doing a loop. Okay. Now we can check in these places where the things are what we expect. So here we can say get lost. We just do a switch over get lost. For an if, we'll do one thing. If you're a loop, we'll do another thing. So then only cares about ifs. So what we want to do, I suppose, because I suppose it's theoretically possible that we'll have something like this. We have a loop inside of our condition. Do we want to allow that? I mean, I don't see a reason why we can't allow that. Yeah, I suppose. All right. So what we want to do then is for our then we want to Actually, no. Yeah, if we see a loop on the top, that means that then is incorrect because it's trying to match up to the wrong thing anyway, so it's fine. So yeah, we can just error this. If it's correct, we can do this. Then if it's a loop, we're looking at the wrong thing. So I guess in this case we can say probably a. It's probably a then without if once again. Sure. Even though we've checked here that it exists. This is also not. I suppose we'll just do this into places for now. All the to-dos off for this. Okay, where else are we doing this? So in here, that's fine. In end, we need to check this as well. Let's do that. We've checked that it exists already, so that's fine. And we just grab these bad boys. Like so. Then in this case, it would be we get rid of these. What's the end of out endings? Comes from there. And then if it's a loop, we do the same thing, just the other way around. I suppose we can assert that this is correct. So what we can do is it's in both places, and then in this case, this will be the loop node index. Then that's unreachable, and then in this case, the loop's unreachable. Because this is once again an internal error if that goes wrong. I'm thinking about this correctly anyway. And now we're at the again stuff. So again is going to function similar to then. Where are we at? But instead of it being this way around, it's this way around. This would be again without loop. Found an again, found an end, found a then. Yeah, good. Just make sure my ands and a's are correct. Going off to up here. Yeah, if we see an again, this is going to switch around. This will be again. Oop. Then in this case, we are grabbing all loop index. Say, I probably copied this somewhere else and it's wrong, but it's fine. Contextually, it'll be figurable. So yeah, we're looking at our loop. We're grabbing the loop, which should be correct because of this. So we don't really need to check here, actually. Never mind. Because it should be guaranteed by the fact that we did it correctly. One night. Because we have some stuff we need to do in our code gen now, don't we? Indeed we do. this the correct location? It seems like it is. So for our loop, we need to, I suppose, just continue generating first. We want to keep track of where we are, so this will be the begin uh, index. Or the, sorry, not index, address, yeah. Which will be the writer length. Then we'll generate all of our loop and yeah, but we need to intercept our agains, go to the right location. Hmm. Ah, yes, that's a point. With the what's happening with the again? Did I actually do this right? So yeah, it's when did it even finish this off? So the end is being set there. The begin is set by loop itself. So this would be node index. So we don't really need a begin then, I suppose. So nothing gets set here. This is more of a, we need to tie the again to a node index. So we actually want to produce an again with a node index, I guess, is the way to do this. Let's introduce an again struct that connects up to a loop. And we can just push this, I suppose. We get our loop index and then we just, where are we pushing some stuff? We're pushing some. Yeah. Okay. And that should be good, I think. Yeah, we see this, and then I suppose we want to keep track of. We want to keep track of a map, I suppose. This isn't the nicest, to be honest, but sure. We'll have a loop map, which will just be a probably an all array hash map will work fine. This will be a U size to a U size, I'm guessing. Which means we are going to need a GPA in here. Sunshine and rainbows. We could probably do this another way, but I'm just going to do this dumb method for now. So whenever we hit a loop, we put a let's do a put no clobber. Seems like a reasonable thing to do. This will be the loop's address, so this will be the node index, and the value will be the begin address. Try that. So what does this fail with? IO writer error. Okay. IO writer error is an allocating error anyway. So we can just catch return error dot right failed for now. Yeah, then this will put that into the map. Yeah, should be good. And then we want to collect the high-level intermediate representation from the current node plus one, so after our loop, all the way to the end of the loop. And we code gen that. Yes. And then we set the node index to the loop end. Seems like what we need to do. We don't actually really need to do anything here. We just kind of want to collect the address and that's it. Then for the again, which we did add in, right? Let's double check. We did, yes. Good, good, good. So for the again, whenever we come across this, we just want to get the loop that it's associated with. Actually, what we can do as well is once we're out of the code gen, we can loop map dot uh, swap remove is fine. It doesn't need to be ordered. Unless it's not ordered anyways, a hash map. Wait. Is it, okay, so what's the semantics on this? I suppose this is if you wanted to keep track of ordering of the map, so it's based on insertion order. So this is acting like an index map. Okay, we don't need that, so that's fine. But that's interesting to know. I will remember that for sure. Yeah, then this should always return true. So we'll just assert. Choose removed for the yeah. That's true if it was removed false otherwise. This should always return true because we put it in here. So if it gets removed for any other reason, something went wrong. Yeah, and then in our again, we can grab our loop map, try and get the again loop. And we are popping. I just want to make sure we are popping. Yeah, the block stack perfect. All right, just making sure. Oh yeah, there we are. Yeah, we'll get this. If it doesn't exist, I don't really want to be producing errors here. We've already verified that it exists though, so let's just do that for now. Yeah, this will be the begin address, and then we can just jump to that. So we, and this will be a, what do you call it? This will be a unconditional jump. That's the one. So let's look for the unconditional jump. AMP. And we want this one, I suppose, will be the one. E9. AMP. I'm guessing jumps relative. All right. XE9. And then I suppose just the immediate. Yeah. They want to jump by. So this should be the current address. So I'll call this address. Then the rail address will just be this. I suppose I don't really need this address at this point. Just do a bit of that. It'll be minus the beginning address. Well, this will be positive. We want the negative, so we actually do want the beginning address. No. Yes. The beginning address minus. Maybe. We'll see. See if that's even correct. Let's have a look at what this looks like in the output. Oh, yeah, this now requires a GPA. It cleans up after itself, though, so it's fine. Hopefully. So long as this is done correctly. I'm looking. Gen up. Oh, GPA. Really, the GPA should be going in first. Did I do that or no? Not do that. Let's fix that. The arguments found 2. Oh yes, all of these now require that too. So let's grab these. The nice thing about recursion. T is incorrect, found use size. Okay, that's fine. I can just I32 in cast. If that's incorrect, then I can't help at this current moment. Found again without a matching loop. That's incorrect, so something's wrong. The question is what? 35 to 40. Doesn't say how many it's SS. Oh no, it does say how many. This was, I'm guessing just add the again, so 35 would be the again, right? Yes. Why is that the case? We see the again. Check the block stack. If it's 0, then we have a... Oh, this is the wrong one. Again, it's here. This is good because there's already a bug. But that bug allows us to see happening here is where the error is. So we're checking the last thing on the block stack and we're getting an if. Yeah, we need to loop backwards, like arrow backwards through everything, and then grab the first available loop because the again should skip over any if blocks and other such things. So we want to go block stack items, block, not like that, sorry, length through that. Then we want the actual index to be the block stack item length minus I minus 1. Then we can get the block, which will be the block stack items, that, and then we can switch over that. Yeah, so if we see an if, then we continue. We see a loop, then we want to continue the outer. Not the best way of doing this, but you know what, it's fine. I'll continue. Oh wait, wrong one. What's there? No, not out of there. Actually, no, yeah, out of there's fine. Then if we come across an if, we just want to skip over that for now. And if we get to here, then we have an again without a... Oh. We're on 3. The node index for the if, that bounds index. Oops. Yeah, the if is at this index. Interesting. I don't know what I've broken there because I haven't touched any of that. What can I have touched that broke that? And we did. I suppose we did do quite a bit of messing around in there. Let's not do a continue on the outer second. Just say if we hit a loop, then we want to break the for loop, and we'll just keep track of some kind of bound. Not the nicest thing, but you know it works. Found equals true, and then if not found. I'm wondering if we're continuing when we don't really want to be continuing. It doesn't help. But at least we've got rid of, I suppose, the dependency on between those things. At least for now. Always add it back. Okay, so if I was to get rid of the +1 on here, I'm interested. No, oh, because it's the end index that's out of bounds. Then is out of bounds. Why is then out of bounds? Because we're getting through the entire pass here, fine. Interesting. So we push in our if and the node index. Get to our then we check that it's an if. Sorry, yeah, an if block. Then we set then to the current index. Yeah, that's correct. I don't see how that's out of range. It might be worth having a look at the output of the high-level intermediate representation. Standard log info. Yeah. It's not the easiest thing to look at, to be honest. We're not looking for tokens, we're looking for nodes. So we're pushing, we're looping, pushing, adding. If we're copying with intermediate, we're not equaling them, then we're not equaling and then equaling. Well, that's something that's already incorrect. Then we're againing, and yeah. So let's fix that. I think I know what's wrong with not equal. It's in the lexer. Tokenization is incorrect. Where are we at? We are. Yeah. Yeah, we're not doing a. Okay, I don't know why all the way down there for. But scanner cursor plus equals 1, which I forgot about. Yep, so we push for add with if we not equals, then we again. So from 366, but 366. Oh, I'm doing it. Hello, hello. Good to see you, Penguin. Back again. The 366 happens in loop. So once we're doing, let's just check quickly whether this is fine. If we was to do if 4 not equals 42 or whatever. Not implemented yet. Identifier? Huh? Sorry? Oh yeah, because we didn't have a space. Okay, so this works fine. So this then is working as expected. It's just once we start getting into the recursion of having a loop, things get funky. It's now out. Oh, it's out of bounds because. Is it okay? So the sub. I don't want to do representation. get rid of this one. The sub one is here, up here. Isn't the same. I forget, because this one will contain only the stuff that's inside of it. That's not the right place. Where are we failing? We're failing 13. Oh, we're failing at making it at all to begin with. So we're giving it this here, which just contains Pusher Media and this is what's inside of the loop, if I remember correctly. So Pusher Media, add if, copying, pushing again, we're not equaling it, and then we're gaining. Yes, that makes sense. Okay. But now we have a sub here, the we have a sub here. The node indices are incorrect. Why don't we? Oh, we never nested any ifs yesterday, did we? Okay, that would probably explain why we never came across this before. See, a sub here isn't going to work. We'll need some kind of starting location, I suppose. Unless we want to start patching all of the indices and remove, getting rid of, subtracting the relative differences and stuff, which is not really fun. We need to fix up this sub here issue that we have going on. To be fair, we could probably do with separating things out. And now that we have conditions, it might be worth rethinking how we do this because we're trying to bend the old system to the new one. Which is fine if we have simple stuff like these, which are just linear, right? But as soon as we have any kind of recursion, we're now dealing with specific issues that aren't particularly fun. Okay, let's have a think. Say we have some kind of this code gen around. We have a code gen to look like. And it might be worth thinking about changing up the operations as well. It's good having the linear list. I like the linear list of operations. But is it worth possibly switching out the is it worth switching out the way we're currently doing the blocks and whatnot, so we can split the simple stuff off into their own section? It's not really necessary though, because it's very simple. It's not like we need anything crazy. So yeah, I think it's fine having everything the way it is currently. Think about the code gen. Right, so we have an if, we have, you know, a +1 in here. We have a then, we have an end, and let's say we just want to return a 42. In terms of operations, we have some kind of op if. This will want to know where its then and its end are. I think that's reasonable. But maybe we have, so we have our, our copy here, we have our M1 or push one, say. Then we have our add. Then maybe it's worth keeping this around. So for our then, we need this, or do we just say we know where this if is? We keep track of where the if is, and then we point this back to the if. maybe. Then, we will have our op push 42. Then our op end can keep track of where the if is as well. And then if we think about how loops would work, where we have, say, actually, let's just add a loop around this. Yeah, if we'll add one onto it, write out a whole little program here, I suppose. So while that's not equal to 3, then we just go again. Push 0. Loop. We have another op end. I suppose we can split these out then. So we have an if end and loop end. They're still just represented by the same token, but we figured this out based off of what we've seen. That way we don't have to check things are correct, they just are correct. Does the end care about... I don't think the end cares about where the if is. I think the then cares about where the the end is. This would be the if end, like that, I think would be how we want this. Whereas the loop end does care about where the loop is. Does the loop end care about where the loop is? Thinking about it. For us, it's the agains that care about where the loop end is. Methinks. Unless we do just go with a classic, loop. Or we'll just go with a classic while. Maybe we go with a classic while and keep things simpler. So, alright, let's do something a bit drastic. We're going to just comment all of this out and then simplify things up a bit nicer. Of x86, 64, const. This is going to be broken for now because we're not actually able to do anything. Let's say we have our high level intermediate representation, or immediate representation. I suppose they're similar enough. We'll do what we were doing before. Here we have pretty much everything. Let's copy it over. Too far up. I mean to deselect. Okay, there we are. Then we can just do our stuff in between here. Think about the nodes then that we want. Where that push, I'm going to call it push for now. So push I64, we'll have our add, our subtract. Also want our errors, so don't forget about those. So our error struct as a tag and the main token size. As a format which we can go about implementing tag. Okay, so we have that, we have our if, we have our while. Okay, so do these. Were they everything? But yeah, and then we wanted our various ends, right? We have our loop end, our if end. Do we need if end? If end doesn't need to exist, I don't think, because this just points to... So if we have an op if, The end doesn't care about where the if is. The if cares about where the end is. No, not the if, the n. The then does. This cares about the end. If we op while and our op end, in this case, the end cares about where the while is. So I suppose we can separate these out then into the while end and the if end, because these will be different. This end doesn't care about what it is, this one does. So we can call this an if then as well, just to mark this as part of the if structure. Then we can do that. Cool. Okay. So we have an if, then we have an if end. We have a while, and we have a while end. I suppose we're going to be having a condition. So we'll probably have some kind of, just a copy, I guess, what it's like how Lua would do this, I guess. We just have a while do. Or we can just have a while end. While then, sorry. And we could just make these the same thing, right? Where we have an if do and a while do. Not really necessary though. Maybe we just go with then for now. Testing Twitch latency. Oh, I might have missed that, but hopefully you saw it pop up. And hello to a new chatter. So yeah, we'll have our condition in here. We'll have our then with all stuff in there. The end goes through. And then, yeah. Syntax is crazy. Oh, this isn't the actual syntax. I'm just thinking over what the actual stuff's going to look like. Thankfully, this isn't the syntax. I'm just want to know what these operations are going to look like so we can properly model them in here. Yeah. I mean, we could do this as the syntax, but it would be insane to get someone to try and write this. It'd be very explicit though, so maybe benefit. Yeah, so the then cares about where the end is as well. So we'll have a while end. I do use Neri indeed. As you can see, I use the most plain Jane version of it as well, where I don't have any kind of bars or anything. Because I found that I don't actually really need them. Yeah, I think this is reasonable. So if once we've hit the condition, we're at our then knows what the end is, so if the condition's false, it can jump to the end correctly. The end knows where the then is, not the while itself. So it knows where the then is because it needs to... We'll just throw up and try out Neri. I mean, yeah. It's super, super simple to set up. I don't have anything crazy. Anything you might want to worry about would be the X11, X11 support via X-Wayland, because Neri doesn't have a built-in X-Wayland support, but it does integrate quite nicely with X-Wayland satellite. It's all in the docs anyway, they explain how that stuff works. And it seems to work well on NVIDIA. My friend has NVIDIA. It works fine for him. He still uses X11 with KDE. Sorry, I was trying to remember the name. Because he's had issues with KDE and NVIDIA. But I'm not entirely sure what's going on there. Yeah, it seems to work nice if just what you have. I mean, I highly recommend it. I've switched to it because I wanted to try it out, and I haven't switched back. So, I mean, that's the best recommendation I can give for what my words are worth, anyway. Yeah, so this should be correct. So the then can jump to the end if it doesn't know where it is. What distro do I use? Arch, by the way. You know. Oh yeah, I use Arch. I've used a few different things here and there, and this is one that I've stuck with. Not for any particular reason, it's just nice. It's simple, I update it every day, it doesn't break. I know people say not to update rolling release distros every day. You want to try Void? I have tried Void super briefly. It looks really good. I really like the idea of it. I just haven't long term used it. Just because Arch works so well for me, I haven't tried to drive it for longer than a couple minutes. But I do want to try Void out more. I want to try Alpine out as well at some point. I know it's good for server stuff. And I think it's used a lot in Docker containers because it's small. So it might be up my alley. I just like simplicity. If something works, I'm happy. That's all I care about. So yeah, the then can jump to the end if the condition is false. The end can jump back to then if the... Actually, no, it does need to jump back to the beginning because it needs to check it again. Systemd virus. Systemd virus? Oh, are you sure? I haven't really kept up with the stuff that's going on with Systemd. I know there's the age verification stuff that the law imposes. Thank you, England. Well, not just England, but the UK. You know, blame us. It's our fault. Just a meme. Oh, no, I know. That's what I was messing around. I also know about the Systemd stuff going on with the age verification. Though I know there's been some drama around that. I haven't kept up with it, though, so I don't know. Yeah. Fun times. We want a while then. So it's not going to go with a while then. I'm just going to keep the token the same between the two. Even though grammatically, in terms of English, it'd make more sense for it to have a while do installed. Linus Droidbot. Oh no. He's been Android. He's been Androidified. Droid Volts. How about yourself anyway, in terms of what you're currently using, if you don't mind me asking, given it's interesting. Nabara. Oh. Nabara's the one that's similar to... Of course I didn't. Nabara. I think I've heard of Nabara briefly. Let's have a look. So it's these... Oh, okay. Okay, ain't too bad. I mean, I don't... As you can tell by how simple my thing is, so I don't really care what things look like too much, but... I mean, yeah, as long as it gets the job done for you, that's the main thing. I mean, I play games, I do everything I want to do. It's not like I play loads of games or anything intensive. I don't really care about first-person shooters or anything like that, so I don't really run into anti-cheat issues. So, yeah. I mean, everything I wanted to do, I've been able to do just fine. But it depends on your workload, obviously. I had the fun of... Well, the fun or the joy. No, I do not have an application manager, I know. I have the fun of using GIMP yesterday to do the... If it loads, this is going to be fun. I just realized I'm also recording and whatnot, so we'll see how the video goes. I had the fun of using GIMP yesterday to do a thumbnail for the video for the VOD. Highly unrecommended. Not necessarily, but for me it's just games. Yeah, as I said, it depends on what you're looking for. It lags a lot. Yeah, Valve is an odd one. Valve is really in for the Linux side of things. And even their anti-cheat works really well as far as I know. But then the native client for CS and whatnot isn't the best, which is strange. Because I've heard other issues with the native client. I'm not sure it's just the lag. I headed off to... down, down, down. There we go. So we have our equals, not equals drop. I mean, I was never a fan of Fortnite, so... Yeah, I mean, they haven't been the best plague on the game side of things for a while now, so... Yeah. Move these up. So I'll put my stack operations up here, I suppose. Arithmetic. And we'll have that there, yeah. I mean, hopefully this node arrangement works out nicely. So the if then cares about the end. That's all I wanted. Struct if end as. You worked on other languages before. In terms of me working on compilers or just other languages, my like custom ones, yes. Not in terms of doing what I'm doing today, which is well, I've done a minimal amount of this before. In terms of like doing compilation the whole way down. So we're doing like no LLVM, no crane lift, no assembler, no nothing. We're just writing the actual machine code and the ELF object out ourselves. In terms of that side of things, not so much. Normally, I just, if I want to compile something, I go for an assembler. I don't really use compiler backends too often. I have touched a few of them, though. But languages aren't particularly hard to make once you figure it out. You know, you're just converting one format into another format and then it's running. So yeah. I'll end struct. This will be the while itself, because it needs to rerun the condition. Oh yeah, no, it's a very interesting subject for sure. There's a lot of stuff you can do with compilers. Well, the actual concept of them are very simple in terms of, you know, one format to another format, and that format executes and you get it from a text format. The optimizations that you can go through on the in-between process, the whole lowering it between different IRs, and then doing your semantic analysis, your type checking, all that stuff, maybe even doing some interpretation of the language, even if it's compiled, just to do, you know, constant evaluation, stuff like that. It's really cool. So there's a lot of stuff you can get into. There's a reason why, well, I say there's a reason why. There's reasons as to how LLVM became so big. not just going to say that it has to be as big as it is and as complicated as it is. You know, there are reasons to why things get the way they are. So it's cool. I think it's the reason I'm even streaming this in the first place, to be honest, was when I was trying to record a video for this thing, but I kept on redoing it. So I thought, just do the stream and then you're stuck with whatever you finish, like whatever the final video looks like, and that's just it. So it's a way of just forcing something out the door. But also, it's not hard to do. Yeah, the devs are lazy. I think the devs are more confused with LLVM, to be honest. They've built such a big thing that's so interleaved and crazy that they can't themselves deal with it. So it's becoming like the next X11, where it's just going to be left alone because it can't be touched. Hopefully not, but you know. That would be funny. Yeah. Well, hopefully. I'm just hoping that if someone sees this, they can see how compilers work and how simple it really is to actually build something like this if you don't care about any of the other fancy stuff going on. And yes, I'm cheating a bit by doing a stack-based language, but you know, who cares? You get the idea. Maybe that would be a fun thing, doing register allocation. Anyway, so this should be fine. Do they really have that many issues and PRs? But I suppose they don't, is the answer, given how many you said they have open. I don't know if GitHub's just a mirror or if this is where development takes place. Just gonna have a look. Backtrack it, there we go. Just trying to find where it is. Oh, it is on the GitHub. Okay, I wasn't sure if GitHub was the main repo or not, because I know a lot of people use it as just a mirror for traction. Not that you need traction as, you know, LVM, I suppose. Oh my god, yeah, it's a lot. It's a surprising amount of ratio between the open and closed as well, which is fun to see. I mean, they're doing better on the PRs, which is good, I suppose. But that's a lot to keep track of. LLVM is written in LLVM. Who would have thought? Um. Anyway, so we gotta go through this. We gotta go through all the tokens via the scanner. I have to remember I need to stay close to this microphone because it's not the most sensitive thing in the world. Right, let's do a while true here, I suppose. Okay. Grab all of those tokens. I need to go all the way past everything that was here originally. There we go. It's nice having the chat over here so I can see when things update, but at the same time I keep on doing that. Maybe I switch that out. Make it not do that. But yeah, it's not even a thing yet. That's fine. I don't know how long the stream's going to be today. We might not even get this working again by the end because I might have to run soon, but we'll see. So for our end of input, we just want to break. Yep. Then to well, for these ones they're simple. Yeah, very simple. These are just going to try notes pen. Oh yeah, we need to token index, token length, tokens PA and token itself. So we append to this, we want to append node. Yeah, okay, so for this, it's not actually really linking any of the nodes and tokens together, to be honest. It's just being used for the errors, which are fine for now, I think. But that'll be something to improve on in the future. Yeah, for now, we just want to, as we add, these will be nice and easy, as I said. Subtract. Do that. Making sure I wasn't lost because I know things get thingy. Do I call tokens nodes? No, tokens and nodes are separate. So the tokens are what we get from the scanner. So those will be, the actual plus, minus, and integers and stuff like that. Then the nodes in here are like the operation nodes. So push something to the stack, drop something off the stack, copy something on top of the stack, that sort of stuff. Yeah. So here we're matching the tokens and then converting those into their associated nodes. So this dot is, I can't even remember what my own stuff does here. I think so. Equals is equals. Exclamation be equal. Equal. This one is drop. That's how I have this, I believe. Then underscore is technically a keyword. Maybe I shouldn't make it a keyword, but it is what it is. This one copies. Just move that back up to where it was. Integer just does a push of an immediate value, which we do need to grab the immediate value. So let's do that again. This will be standard FMT parse int 64. The buffer will be a slice, which we'll go in a second. And it will be base 0, so it just figures it out on its own. scanner token lock start, token lock end. Then this can technically fail, but the only thing we care about is overflow. But we'll do this anyway. We'll say there is an error, or valid token, valid integer. Let's just get those written out. So we'll say switch tag. Valid to valid to. These aren't particularly captivating messages, but you know, they work. So let's do a switch on this. Not switch, we'll do an if on this. Don't need that anymore. Okay. And if this fails, we want to do an error. So errors. And the main token will be the current token index. And same thing for an invalid. If we come across an invalid, we just want to push an invalid token. Yeah, that should be the basics done. So if we just have yeah. Okay. So yeah, now we need to get to the ifs and whatnot. So starting at the beginning is really the easiest. So let's do that. So if we come across an if keyword, we need to know nothing, I don't think, because we don't keep track of anything in the if. We just pushed that there was an if. This is easy to do, thankfully. But we do also want to keep track of other information, such as the fact that we did find an if, and then because we're going to need, we don't care. I suppose we care about the fact that we saw an if, but we don't care about where it is. You know, we just need to know there was an if, so that when we see it, then we can say, all right, we're inside of an if, then, and then we can get the end for the then part too. Yeah, do that. We're essentially just moving the blocks into here, which is nice. For the ifs and whatnot, the syntax is going to be Lua-like, yeah. So we have like a if, put your condition in, then do your stuff, and then end. And then I think for the while, we have a while condition, then stuff, end. Obviously, Lua would do a do here instead of a then, but I'm just using the same token for it. But the rest of everything else is just reverse Polish notation. So, you know, do all your stuff like so. I don't really need this actually, to be fair. I can go. No. I'll keep that around because that's useful. Yeah, I know. It's messy, but I'm just trying to keep things basic. You know how the pain goes. I think I'm just going to define the actual. Nah, there's no point defining the block. Define the block down now. The reason I'm doing it like that, by the way, with having the if, you know, wrap the condition. Reverse Polish notation being easy to. I mean, yes and no. Well, not really. No, yes, for sure, to some degree. But associativity is really not too difficult to do either, because you just do a prat parser, and they're not particularly difficult to understand or implement. So, I mean, to some degree, I suppose, yes. But it's not really hard to do the other one either. I'm just doing this because I want the assembly we generate to be a bit easier to do. So, we don't have to do any register allocations or anything like that. We just use the stack, which we could do anyway, to be fair. But yeah. Say there is an if and a while block. And then for the blocks, I think we want to keep track of. Yeah, we'll keep track of where the difference between a while and an if is just the end, right? Not having information. I'm kind of interested to think about, like, can we just combine these into one structure? That'd be pretty funny. So if we had a while on here, this could be an optional thing. Yeah, so those unions. Yeah, I wonder if we can do this, and then if we actually end up having something here, the if then magically becomes a while. That would be stupid, but maybe fun. I'm not going to do that now, obviously. That would be something. Anyway, we want to keep track of, well, the ifs, we want to keep track of the then, which may or may not exist at the point of declaration, but it's fine. So we'll say if then use as. This will end up being a union enum then. And for the while, we need to keep track of the actual while itself. So it's going to be while. And the while then. Yeah. I mean, we could reverse post notation the actual if itself, right? So we could have the condition come first, then have the if. And then if this is the case, we do all the stuff between that and the end. And that means you don't need to jump because this is just your block. So maybe thinking, because your while would be the same, right? While end. So while the condition here, but yeah, problem is with the while, you still need to rerun that condition. So you'd have to know what part of this is the condition that stays around. I suppose the condition comes at the end. So this is more of a do. The do doesn't really do anything though, other than set a point in which you can jump from. But that's the same as what we're doing now anyway, so it's fine. So let's just get that stuff tracked, I guess. If we come across an if, we both push an if operation or node. So we've figured out. And we can append the blockers. And this expects an if then. Which is currently just undefined because we don't know. Same thing for while. Keyword loop. Okay, let's fix that. I forgot to switch that out. There we go. Go in. We all hit up PR. And then we're also missing the while is just going to be the current node index, which is the nodes. Yeah, then it's just resistant until we get past the condition. So here, we come across a then. Want to look back, I suppose, to see what the current block is and make sure we can create a block out of it. So we'll fill. Don't really want to pop it, I suppose, because we just want to get it, because we still need to modify it. Let's just get the law. Or null. Cool. Block. Then we can switch over. And we want to get this. We want to get this mutably, don't we? So actually, we want to do items. Yeah, so we'll do an if. It's not 0. Close. So we can do that. Happy I know? No? Why no happy? Oh, because I'm doing this. I've already checked. There we go. What's the point? I don't think you can do that, can you? No. So yeah, I was just wondering there. So no, in Rust there's a lot of that strangeness, but thankfully it's consistent. Yeah, we'll get that last block and then we can switch on it. Then if one thing, if it a while we'll do another thing. How do we do whiles again? I think we just do while now. Why not? For these cases, these are unknowns, but we do want to push. Actually, I suppose the if will contains information then, because the if will probably link to where the then is, so that we know. Is that true? Maybe not. Here we'll say if is append the then with an undefined. Then we'll take the if, we'll set the then to be the node's items length. Let me just do that first. So yeah, we say that the then is here. We inside of the if that block that we've defined, we then add in our thing, but it has an unknown if then yet. Then for the while, I think it's pretty much going to be a similar story, right? So instead of ifs, we have if while then, and the while's already filled in, right? Yes. Okay, good. Just checking. Then if this isn't doesn't exist, we will just add an error to the errors list. This will just be what then without if or, well, I suppose. Right, all found if, not if, found then without a matching if or while. Symbols. We'll add more stuff to this as well, but it's fine for now. So while and if are done, then is done, end is the next one, I suppose. We're not going to have an again anymore. We're stopping that nonsense. Well, thanks for the follow, by the way. Glad you're enjoying the stuff. I know I'm not the most entertaining guy. You know, second stream and all, trying to figure this stuff out. And I'm not exactly a excitable personality. Thanks. Let's see. Where are we at? Want to get rid of the again. None of that hype stuff here. Yeah, so again's gone, and we just need to fix the ends up now. So, end, we need to grab the block like we're doing here. And in this case, it'll be end without if or while. End without matching if or while. Perfect. So, just go up here. This is much cleaner than it was before as well, since it's no longer just tacked together. So this is good for the long run. Yeah, if we see an if, we want to see an if. We want to. The only thing that's on there is the then. Actually, has a point. Oh yeah, and then we're putting the if then here. So we want to grab the if then. We want to get that from the nodes items. Then we want to. We expect this to be an if then. We want to set the if end to the nodes items length. Okay, that's fun. All right. So then we just want to append our if end. Do we need these then? I'm wondering. I suppose it's useful to have these. It's not going to hurt anyone, is it? I think this is a similar case for the while. So we'll grab the while then. We'll set the while end. Yeah, the while ends. What? Wait, so the while ends while. The while ends while. Yeah, okay. While ends while. Because this points up to here. We've already filled in the while end, correct? So, while then. Yeah, the while then points to the while end. Sorry, this is racking my brain around this. So this should be set to the while. Yes? Yes. And the while end has this as well. I'm confused. while then, while end gets set to the node item's length, right? Okay. The thing is, do we need to do this? So we set up the while. We say the while starts here. Then the while then is unknown. Then up here we set the while then of this block. No. Where's the while being patched? That should be in the then, right? Ah, we didn't actually do this. So the while then gets set to this, and then the while then gets pushed with nothing known. In this case, the then's end gets set to that. Okay. Finally making the brain work here. And then we set those because we grabbed the while thens at the correct locations. And then we set their ends to those. We'll just have to print it out and make sure it's correct, I suppose. I'm not entirely sure if there's another way of doing this. Those all know it's incorrect or correct once we break. Yeah, then it's just code gen time. Let's forget about the code gen for a second. And let's just print out the high level intermediate representation. Hear you. Actually, I want to not do that. I want to go through the node. So here node. That way it's just a bit easier to look at. Instead of it being one long string of stuff. Put that back in then. Fix it. Yeah. 228 there. Island is that. Incompatible types. Okay. 203. I'm sorry. Avoidance. 18. Oh. Well, that seems like it was an error. Clerical or otherwise. Not implemented yet. Identifier. Oh, because, yeah, we're actually trying to do this now, aren't we? So, let me bring this in here and comment it out. We should probably add comments to the language. I haven't done that yet. It is what it is. We say 1, 2. Let's just see what this produces. Yep, makes sense. Good. All right. And then if we have an if, 1, then 2, and what does this look like? So if as a beginner we push 1, then oh yeah, let's also print out the position of our nodes. So the index of our nodes, not position. But how does this work again? Is it that? Oh, I'm not going to worry about it, to be honest. It doesn't matter too much. Yeah, we push, then is at 4. So the end's at 4, which is correct. The end is at 4. So that will mean once we're doing our stuff, we can know our ranges of tokens correctly. So that's good. Let's just check the while is correct. So we'll say while 1 and while then this points to 4, which is correct, and then the while end points back to 1. We want it to point to the actual node, though, so we want it to point to 0. So why are we doing that? It's set to the while's while. So the while sets its own while correctly because it's not doing that before. So we can just do a bit of that action. That should fix that. Yep, that points to 0 now. Perfect. That points to 4. And then that points back to 0. And then you can loop through things until we're done. Okay. This is set up much better now. So if we was to add in some stuff, let's say we have 0 and then while copy 0 and 4 are not equal, then we want to add 1 onto that and then continue doing that until that's true. Have a look at what this looks like. Why not exit with 1? Why the exit with 1? I'm not sure about that. Anyway, so we push 0, then while copy 4 not equal, then that goes to 8. What's powerful, sorry? Also, I like with the L in the one word. That's great. So then, so there, back to 1, then to do the stuff again. All right, just making sure things are correct. Let's try and nest some stuff. Oh, I mean, it's there for the nicking. It's not my creation, so feel free. If it was my creation, I don't mind. Let's say if we wanted to move this into, we can't really break that, can we? Let's say if copy that is 1, then 2. We'll put yeah, let's just, this is gonna be an odd one, all right? Then if we don't have else's at the moment, so I'll just say not equals then 2. So it should add 1 to it if it's 1, and if it's not 1, then it'll add 2. Oh, let's say 0, sorry. So it'll add 1 and then add 2 for the other iterations. Okay, this is incorrect. Okay. This is why I wanted to test things like this. Okay. We do a not equals here. Then our then is not being patched correctly. Are we ever popping things? Oh, hello. I missed the follow from Boscans. Thank you. It's a bit hard. It's right behind the microphone in the corner, so I'll see it when I see it. Hopefully I'm not too late for you guys. So where are we? Where are we doing our ends? We're doing our ends here. So yeah, we're modifying them, but we're not popping them off. So we need to do that. And that can be done pretty easily. We say blocks pop. And we just, I suppose we can just assert that they exist. There we go. That seems to have fixed that. Let's check these side by side. So we have our 0, we while, then we copy, we push, we not equals them. And this then should go to this end, so 22, which is correct because that's the last end there is. And that goes back up to 1, which is correct because that's to there. Then we have an if with a copy, push equals, and then we have the then for the if, which goes to 13. 13 happens after the adding of the 1, which is correct. And then we have our next if, which copy pushes 0, yep, and then not equals them. Then that goes to 21. 21 goes between, so between 21 and 18 is push and add for 2. That's good. This is seeming correct to me. Okay. That's good. Alright. But this should be a lot more powerful than how we previously had things set up. So when we do our code generation, we can know what nodes connect to which nodes correctly and more easily. So when it comes to patching things up, we'll have a nicer time, at least I hope. See, if this was something like RISC-V, we have the nicety in RISC-V where all instructions are 32 bits. So you'd be able to just, pre-calculate, okay, there's this many instructions in between, so your next address that you're jumping relatively to is this number of bytes away. Whereas with x86, you don't have that luxury because instructions are various widths. So we just have to actually do the stuff, like generate all of the code and then patch what we've previously written with the correct relative jumps. That's fun. Or we can have an in-between step where we generate the instructions but don't actually generate them fully and collect the lengths of the instructions. Then we know where we need to jump to, and then we can generate the actual instructions with the known addresses. But that's 2 steps. We don't really need 2 steps. We can just patch things up. Yeah, I think ARM's similar, if I remember correctly. ARM has whatchamacallit, known instruction lengths. I can't remember. Maybe not. I can't see anything that comes up quickly. I'm going to search for too long because I don't want to get too off track. I do that very easily. So, but yeah, it's nice having a known instruction width, but we don't have the luxury, so we can't. Unless someone wants to go about redesigning x86. Anyway. The good thing about this whole block thing that we have set up now is if we want to add another block in, say we want 4 loops that are separate from our while loops, we can do that nice and easily. If we want to add in else for our ifs, we can add in else for our ifs as well. Stuff like that would be nice. I suppose the goal is to just get this compiling. Let's just get the basics compiling first, I suppose. We want to make sure that we can compile, 1 plus 1. It's pretty important. And a lot of the code gen shouldn't change. Other than the patching stuff. So what we'll do... I like the writer. The writer's nice, but at the same time, the writer is a bit annoying in the sense that it's a writer still. It's good because it has all like the write int and write bytes and stuff like that, which we want. But at the same time, it's not just an allocation error when it happens, it's a writer error that happens. Yeah, okay. I suppose we'll just keep the way we're doing it before the write on them. Taking all here. I do want to add in other levels of intermediate representation as well for type checking and stuff like that, but I'm not going to worry about that for now. Here we can take a writer, just be a const, a standard IO writer, for which this can error out with error. No. Maybe we have separate functions for doing specific bits of compilation. So, if we hit an if or we hit some kind of block, we can jump into another function for that. We'll see how that goes, I guess. So for node. Oh, before we do anything, I do want that assert back in. So debug assert. We want to assert that there are no errors. Just so we know that we've been given a more than likely valid intermediate representation. That'd be very useful. And here we should be able to switch over on nodes. Do we need to be able to jump between nodes? I don't think so. We need to be able to patch nodes, but we just want to write out everything, so we should be good for that. We have a lot more nodes than previously, but that's fine. Yeah. bit of that, just so we have some. Not unreachable, not implemented. Yeah, we'll also want the Linux stuff back as well, so let's do that. Right. This isn't going to change, as far as I can think. We'll just keep the same code gen for the Linux exit as we did previously. Although I might make like the whole pop move and stuff, not written out manually each time. That'd be nice. Yeah, let's do that. It was say some kind of register, which is just an enum u3. Just grab what the registers are in here. I'm not gonna worry about the extension registers for now. I don't care particularly. Lowercase, that. Technically, these aren't racks and whatnot. These are just the actual encodings. So that for this, yeah. And we'll say the rex is a pat struct 8. Have the rex. There we are. It has its fixed bit pattern is a 4, which is 0b0. Then we have w, r, x, and b. These are just going to be booleans set to 4 by default. This packed struct stuff is so nice to have. I really wish it was more commonplace. I mean, maybe it is more commonplace and I'm just missing it. Who knows? Very possible. And we have our mod rm byte as well. So this will be another packed struct. Right. So we have mod, the reg, and the rm in the other order because it's Lillian. So this will be a u3, a u3, and a u2. And that should just help us write out some stuff a bit nicer. Yeah, okay. So now we can have something like a push reg, say. So taking a writer, standard IO writer, or taking a register, standard IO writer error void. And this can just do what we would want to do for this. So in this case, we're just taking in a register and then we're say as you a. Actually, no, we don't. I don't think we need to do an as you 8 for this. Actually, we might need to because it doesn't know what it needs to be. Yeah. So we'll do an as you 8 for the register, which will be in from enum. And then that will just add on to that opcode, and that will be us pushing a register. Very nice. Then popping a register is the same thing, just a different opcode. I think it's 50 instead of 58. Wait, that was pop. Sorry, it's 50 for push, and then pop is 58. Yeah. Double check. Push 50. Yep. Push is 50. Then we have our move immediate, which we can copy as well. So let's do that. Move imreg or regim, I suppose. The other way around. writer reg. So just be the DST. I suppose. Say source. We'll say DST for this, and then DST here. Register. Writer error. Void. There we go. So this is our Rex, and it's Rex with an R set. So we'll say write struct. I believe we can just write struct like this anyway. Oh, it's not writer, that's why. Struct, which does handle packed structs, which I did check previously. Hopefully that hasn't changed. Then little endian as always for x8664. This one is going to be as a in from enum dst. Yeah, because we're just moving it into a destination register. And then we want the immediate. So the immediate will be, so it's an i64 in this case. And that'll be that done. What other kinds of things do we do? Add as well. We subtract. Do indeed subtract. What else do? We compare. We do a conditional move if 0. We do a conditional move if not 0 as well. Very cool. That's another add. So that's already handled. Well, let's add immediate. We have add. Yeah, so we do. We have add register, and we have add immediate as well. Okay. Both of those. And just take those for now and get those converted over to separate functions. And it did nothing. Of course. Of course. Okay, add. Subtract. That's not what I asked for. That's the one I wanted. If I held down the right thing. That. Back in the correct order. Here. Conditional. Another add. And we'll take those. There we are. That's awesome. A bit of that just to get things situated. All right. Say add reg. Source register add IO writer error. Rex prefix need mod rm. So a mod rm in this case is this one was RDI RSI. I believe RDI is on the right in that in the RM. Also destination depending. I know that's the problem. We can check with an output, see what if it's correct or not. So we'll say mod rm. The mod is going to be direct. The reg we'll say is dst, and the source is, so the rm is the source. And then we need to convert these into integers, which we can do very nicely just with a enum. Nice and long. That should be add, I think. But RDI is what? RDI is triple one. The RDI is on the right. Yeah, so it's the other way around then? STRSC. And we have the same thing for sub, but sub is 0x29, so it's the same elsewise. Compare is just sub but 3b instead, because compare is sub. Make sure they were in the same place as well. They are. All right, good. And then we have a conditional move between two registers. Say dmov z. Rex is 0. So this time the destination's on the left, not right. So DST SRC. And this changes, by the way. There's some instructions like add and whatnot will have the exact same instruction, but they'll move whether the destination is in reg or RM because specific extension bits may need to be set and also interact with the SIB bits and stuff like that. So you may need one encoding versus another encoding depending on what you're trying to do. At least that's my understanding of it. I could be incorrect. Who knows? It's x86-64. No one knows. So these writer-writers need to not be writer-writers. They need to be just regular. And then we don't need a, well, we do need a mod RM, but we don't need a Rex because it's 64-bit. I mean, you can. I believe Zig does allow up to the 64-bit integer limit with integer literal sizes, or integer literal sizes, integer types sizes. So you could have a U60,000, as far as I know. Not sure how well that'd perform, given it's doing a lot of magic on the stack, I should imagine, but you can. I say magic, it's not really magic. You know what I mean? So, this one's not 0, not 0, 45 instead of 44. It could be cool making a virtual machine as well and then targeting this for the virtual machine at some point. That'd be pretty cool. Okay. And then we have another add here, but this is add immediate. So I suppose we'll stick this up with the other add for now. So it's with the other stuff. Take this, we'll say add reg immediate, so dest immediate. This one does need the rex. This one is this. It doesn't use an opcode extension. It uses a mod RM. Oh yeah, it uses I believe the reg as an extension of the opcode. This one. So in this case, we're doing 0 as the extension, because if you do another one, it turns into another instruction. It's a decently complicated instruction set. Then this is an I32, which is fine for our use case. We don't need anything more than I32. Yeah, I think that will. Again, and then we're doing specifically that, but we can do that once we get there. All correct. Hopefully that's all correct. Let's say we could also do this for all to be pretty nice. Since we don't really, we know these are writers, right? So we don't really need the full name. Not really a problem, I suppose. Either way, though. So I'm also going to rename this to Reg, because why not? Everything else is shortened down. Okay, so if we want to push something, we would want to do an x86-64 move reg immediate with our writer, which I'm also going to call W here. We'll want to do that into racks, which will be AX, and we want to push the immediate value. Like so, and then I'm going to try that, and then we'll also want to push reg AX. Much nicer than what we were doing before, where we were just doing these in place everywhere. Especially for things like this, where it's very easy to mess them up. In this case, we want to do a 664. We want to add reg immediate. We want to do this to stack pointer. And we want to do size of 64. For copy, we want to try x86-64 pop reg into racks, which is a scratch, so this will be AX in our case. Then we want to just push it twice. For add, we want to x86-64 pop reg W or RSI or DI. So like that. Then we want to x86-64. We want to add the two registers together. So we want DI SI. Then we want to push DI. Much more readable, so long as we're actually doing this correctly anyway. Much more readable. Then this just be the same, just with the subtract instead. I mean, we could copy what we were doing down here a bit directly if we wanted. So yeah, for equals and for not equal, let's copy these and just copy what they're doing. I didn't really need to copy the entire code. I could have copied just the bits that mattered. But it is a bit late now. Tis a smidge late now. That. We do that. Let me do this. Do that. Grab all of that, get rid of it, do that. Same thing here. That way we're just keeping the comments, which is all we really care about for this. So these act the same up until the conditional moves, which is nice for us. So here we just do an x86-64 pop reg into our SI. Then we do it into DI. Then that's that done and that done. We then try x86-64 compare DI with SI. We then x86-64 move reg immediate. Yeah, we move reg immediate. We move into racks. We move 0 into CX. We move 1. Then we x86-64. This is where the conditional happens. So I'll just do this. Then we push 664 push register AX, I believe it will be. Yes, indeed. And let's just get rid of those, and then we'll move there. Like that. Okay. Try x86-64.reg w AX CX, like so. That should be good. And then we have our ifs and such. For now, I am going to. We need to update these as well. For now, I'm just going to put this comment here. Let's update these quickly. So we want a try x86 pop reg W. Let's call this W to keep consistent now. Say DI. Then we want to try x86 mov reg immediate W. Just be AX and 60 because it's the exit syscall. Then we want a syscall instruction. So we want to say syscall W standard IO writer exit with standard IO writer error or void. These are all incorrect. I have just realized. Let's void. Perfect. Then here this will be a W dot write all. I believe it's 0x0f 0x05 is syscall. Let's just syscall this quickly. 0x05. Perfect. Now we can do syscalls. So we'll try x86 syscall W. Yeah. Let's try and do all these things. So we'll try and push 1 and 2, add them together, negate 1, which bring us back to 1. We'll then copy it and then drop the copy. We'll check whether it's equal. Let's not do all this at once, actually. Let's just do all the symbols. 52 arguments found free. You and doobly doobly diddly doo. One frere. Yes, so found UA found. Yes, indeed. Because I said right by, didn't I? I did indeed. For any of these where I'm writing the byte, I will write the struct in little endian. Expected type. Allocating. Here's the thing, we do actually need the allocating writer in here to be fair, so maybe we do that. And then these don't care what the writer is, because we need to know how many things we've written. Yeah. Okay. Let's sort this out then. All of these calls be the writer. Not the best solution, but yeah. Yep, and then this requires this instead now again. So it's okay. So we're still we can just debug print this still for now. Why not? And we're looking at the output already. Perfect. So here we're just pushing 1, so we're moving 1 into racks. And then we're doing our syscall right at the end, so we're popping into RDI and then exiting with the exit syscall. So that seems to be correct. Try and add some stuff together, see if adding looks correct. So pop RSI, pop RDI, we add RDI and RSI, and then we push RDI. Seems good to me. And subtract should be the same, just with a sub instead. Looks good to me. Dropping something just adds on to the thing. That's exactly what we expected to do. Copying something, pops it and then pushes it twice. Good to me. What other stuff have we done? Equals or not equal? Yes. If we want to just if two things are equal, we pop them, compare them, then we move 0 into racks, move 1 into RCX, then we need to make sure this is correct because it's currently doing on 64-bit. So that's compare, right? Yeah, indeed. So compare does have a rex prefix. Oh no, the C moves don't though. So let's do that. I thought they didn't need it, but apparently they do. Okay. Yep, and then we push racks. So that should be correct. then not equals is the same thing. It's just a not equals instead. Yeah, that looks good to me. A quick brief look anyway. What else have we done? I'm just gonna have a drink quick. Okay. I think that's everything we've done so far. So we've just got the basics re-implemented again. So if we wanted to do 1 plus 2, that should 1 plus 2. We now have 1 plus 2. Right, yep, 1. Push that, 2, push that, pop both of those, add them together, push it back, and then go. So if we re-enable outputting stuff, we now have a bunch of stuff. Let's try and run that. It says 3. Okay, so we can add numbers still. If we do negation, we should get -1, which will be 255 because it overflows. Let's do this instead. 2 minus 1. That's more clear. All right. And then if we say 20, 22 plus minus 12, it should be 30. Right, 12 minus, it should be 30. Perfect. All right, that's correct. I'm too far up. What else can we do? We can say 20 duplicated, and it together is 40. Perfect. Then we can just drop that value and we should see 1. We do. Perfection. If I say 42 here, just so we show what's we're managing, so that'd be 42. Good. Okay, so this is going to be more interesting because now we actually have to do some backpatching and keeping track of addresses and other such fun things. Maybe the codegen should end up as a struct, which contains, Trump addresses and stuff like that. Could be interesting. Or useful more so. If we come across an if, we don't really need to do anything I can think of other than check whether it's true, right? So what happens when we come across an if here? We create a sub here, which we're not going to be doing. We're going to be doing this differently now. Then we pop the value, we test it, and then we jump relative if it's not 0, which will be to the then. In our case, we just skip over the if, I think. And then once we hit the then, we will be able to go back to our if location and know where to jump. So we'll just keep track of blocks like we're doing in here, but the blocks will instead contain addresses. Methinks, anyway. Something like that, anyway. Maybe. So, I think that'll be the easiest way to do this. How long we've been going for, let's say. 2 hours. Not too bad. So yeah, let's, so we're going to need to add test and jump 0 to our list of things we are able to do. Are there any other ones that we need to be able to do? I think that's the only ones we don't actually know how to do yet. Let's get those added quickly. Do the easy stuff first so that we can procrastinate a little longer. So let's say test reg w standard IO writer. Standard IO writer error void. So we need our rex. We need our code, and we need our So this is RDI, RSI, but both of these are SI, I believe, right? Which one's that one? Sorry, RDI. Both of those are RDI. Okay. Okay, Smoky. So I don't even know which way around these go. I'm guessing it would be the same as the compare. Let's see why not. Let's go have a look. So CMP. So we're using which one? We are using 3B. 3B is G then E. Look at test. We're using A5. A G and E. No, that's E then G. So we need the other way around from compare. So this will be the destination. This one will be the source. Okay, hopefully anyway. We'll see. I'm not going to move test up to be next to compare since they're related instructions. And then we just need our jump not zero. Immediate. Could be a relative immediate. Rel. Eh, either or. We just grab this so we're not duplicating efforts constantly. Then this will be a relium, I suppose. I don't know. We'll say I-32, I believe this is, right? Yep, indeed do. Diddly do. How diddly do, neighbor. Anyway. That should be everything we need. For that, anyway. And that's all of our procrastination finished. So if we see an if, we're just going to mark that we saw an if. So we'll say box standard array list. Actually, no. So we know the difference between our blocks now because we've generated the difference between them in our IR. So I can actually just keep track of, ifs, for example. And then we can have some kind of, if construct, right? And then same thing for whiles. Some kind of while construct, maybe. Since we know that we've already separated out the ends and the thens between them. Do we need this? Do we need them to be separate in any capacity I can think of? If we have stuff nested, that's an important one. I mean, do we even really need them to be separated out on the node level? Obviously, the while end contains some information that the if end doesn't, but can we just have that be optional information and such? I'm going to leave them separated for now, though. But that's an interesting thought. So yeah, so we come across an end, sorry, an if. We just want to say we've seen the if. Do we need to say we've seen the if? I don't know. I just think, let's just say we ignore the if. Then we come across an if then. So we've generated all of our condition because we just carried on going through everything, right? Then we come across the if then, which says we finished parsing our condition, so we now actually want to check our stuff. So to check our condition, we want to do what? I should have kept this about. I forgot to do that. So we want to check our condition. We want to pop this, test it, and then jump if it's not 0. Let's do that. So we'll say try XE664 pop reg w RDI. Sorry, not W. W, right. So then we will test reg. This will be di with si somehow. No, this is with itself. Yeah. We just didn't update this to be di. This is di because we want to test whether it's 0 or not, and then we want to jump not 0 by X amount of bytes, which we don't know yet. So this will just be undefined because we need to come and patch this, right? And the way we can do that is we need to keep track of where this is. So yeah, we do need a stack here. We'll say var if thens. No, yeah, if thens. I mean, we could keep this all in the one stack to be fair, but I'm not going to worry about that. So this would just be where the node is, not the node, where the address is that we need to start, fill in. For empty, we'll say defer if thens dinit GPA, which means we do need our GPA in here. That'll be a standard mem allocator out of memory. All that. Even though both of them mean out of memory, given we're using an allocating writer, but it is what it is, I suppose. What about Odin? I have very briefly tried out Odin. I haven't tried it out too much. I do like the language. I think having a ton of stuff in the standard library, especially for what it's targeting, right? It's targeting game devs and people who are interested in making graphical applications and stuff like that, right? At least to my knowledge. It has matrices built in, it has vectors built in, which are just matrices, I suppose, but it has all of these things you would expect if you were wanting to write a game or graphical software, which is really, really cool. If I needed to write something like that, I would probably pick up Odin and try using Odin more. I don't really write a lot of graphical applications though, so I haven't had too much of a need. And if I do need to, I normally want to do other stuff, which I tend to like another language for, because I haven't really tried out Odin, so I don't know it too well, right? Not to say it can't be done in Odin. Obviously, you can bash a screw in with a hammer as much as you want. It's just not as effective as using a screwdriver, right? So, I don't know. I'll give it a go at some point more in depth, maybe on a stream or whatever, if that sounds like an interesting concept. But yeah. Thing is, I don't really align myself to any specific languages, right? It's not useful for anyone. It's not useful for the language. It's not useful for me, missing out on tools. It's not useful for telling someone, oh, this thing's bad because X, Y, and Z esoteric reason. It doesn't really matter. There are objective reasons why languages are good and bad, and they are worth discussion, right? But I don't like the whole culture war that's currently going on between different languages. I like a Zig. I'm using Zig. I use C. I've used Rust. I've used JavaScript previously. I've used Python previously. I wouldn't touch Python now really because I don't need to. But it's a language that people find useful. As long as it's useful, it's useful. So yeah, we're keeping track of our if-thens. So our if-thens are going in there. Like to use Python. I mean, if you got a use case for it, go for it. I know they've got a lot of machine learning stuff in there and whatnot for a custom building system. I tend to prefer the build system be in the same language because when you have multiple languages in a repo, things can get a bit finicky. You have to start. What's the word I'm looking for? You have to start. Oh, what's the word? I can't think of the word. Oh, you have to start making the different build systems. Oh wow, I lost it again. But you have to make everything work together cooperatively. That's the word, which can be a bit of a hassle. So you end up building it. You end up needing to either bring in another system. If you start bringing in make, so you can have your Python scripts built into at the same time as your C, but in the correct order. So you're generating a header or whatever, and then you can compile everything nicely together. It's a bit of a nuisance, I find. But I mean, yeah, if it's something that you want to do, I mean, go for it. It's one of the things I like about Zig is Zig's build system is written in Zig, so I just need to write more Zig to make the Zig build. It's one of the nice things about Zoding's knob library, knob.h for C, is it's in C, so I only need a C compiler to build more Cs. Yeah. If I'm using Python, I would use Python as my build system because then I'm just using Python to build more Python. I feel like that ends up working the nicest. But if it's just to have fun, I mean, go for it. I've messed around with building build systems before for languages that aren't the host language. Yeah. So here I want to, yeah, keep track of the thens. So it will be, where am I at? I'm here. So I want to say, it's this that we need to edit, right? We need to edit this byte here. It'd be nice to know how big. We could have a, we'll just return a usize, I suppose. So we can say address equals, this isn't amazing. Is it, I kind of want to know this is an allocating writing in here as well so that we can get the amount of written stuff so we can get the address that we need to patch up. Okay. So what I'll do for now then is I know it's going to be at the end. So I can just say try if thens, we'll append GPA and we'll append the written length minus size of, not sin, size of an I32. And that will bring us to where we need to be for this. To do a better way to track the address of bytes that need to be patched. That'd be nice to have. Yeah, but then once we hit this end here, we want to if thens pop. And we're assuming this exists. If it doesn't exist, something has gone wrong. Yeah. So this will be the if then index will be that. Oh, and this is the end. Do we need the if end for this then? Can't really use it in this case, I don't think. I think we need to just patch it like this. Interesting. Yeah, maybe the if end isn't useful here. But it'd be useful in other other backends or other code gen targets. So we'll grab the unless no, that's not gonna work, is it? So we'll grab the if then index targets, and then we can just grab the. So we're appending the byte that needs to be fixed, yes. So we can grab the written length. Then we can add size of I32, I believe, and then take this and negate the, yeah, and negate the, sorry, if then address, not if then index. Then this will be our relative address, I think. Then we can take our if then address in our w written plus size of i32. Then we can write this in here. I think would be fine. Yes. How do we do that here? I think we use a standard FMT, not FMT, so standard mem. Right. Yes, we do. That negates. This stores the negated on already, so this would be that to plus size of i32. Then we store the relative address, which if we just grab this and do that for is the end address and the then address. Okay. I don't know if I don't need to negate. Sure. Suppose we'll find out. Anyway, that should be it for the end. We should be able to that. Let's stop doing this again so we can look at the actual output. This needs 3 things. It does indeed. GEA. It cleans up its own memory, so it's fine for us. It found U size. We need to int cast. It's fine. We do that. Say i32. We expect this to fit. If it doesn't, then we'll just die for now, and then we'll figure it out later. So this does nothing currently. Yes. Okay. So if we say if 1, then 42 L end. So we push 1, we pop racks. Sorry, we push racks. We pop that into RDI, we test it with itself, and if it's equal to 0, in this case, no. Should be not 0. Right? Not 0. Jump. I don't know if that's correct or not. Anyway, it jumps by that. Food delivery or cheese bean patty. Very tasty. But before I eat that, I need to figure out what's going on here. We'll be jumping by 32, so 36. This is already too far. If we grab this and we just do that, that's 36, right? That's too much. We need to jump less. I don't know why it's so much. What is this value? So if we standard log, I feel like we did this yesterday. The same thing. Maybe it was fine. I can't remember. I don't think it was. But let's try. Let's just. It says 42. So if it's 1, it's 42. If it's 0, it fails. Okay, so it does try and jump somewhere it's not supposed to jump. Okay. Good. At least the output is incorrect and known to be incorrect, I suppose. But yeah. Uh, so maybe it does make more sense to not do this. Yeah, but do this here, so this is more in line. Possibly. So that's 1, and then this is 1, this should be 42. Okay. All right, we'll do it that way, just so we're not doing so many adds and minuses of I32s. Such. Okay. Tasting good so far, so recommended. I do like myself a Jamaican patty. That's so tasty. I haven't had a cheese melted one before. Cheese and beef, sorry. That's good. All right, so we can do ifs again. Let's try and do not ifs. The wall doesn't have any information. So I think it's going to be the same where we're doing this again. Yeah, we're checking whether everything's correct. And then we're keeping track of this, but in the while. And just copy this. And we'll do this in a separate thing for now. Probably be better to just patch this in place, which means we need to invert what we've done. But it's fine. We'll do that again at some other point. Anyway, so we do that. If it's not, so this is, yeah. Do this, we append the location, and then we hit the end. Yeah. And to do that, it would be, so if it's 0, we want to jump to the end. Otherwise, we want to continue and then jump. So we need a jump 0. Let's have a look at jump 0. So this is 84. I think this is 85, right? This is 84. So oh, maybe these are. So this one should be jump 0. And then this one will be jump 0, I suppose. And this will be 85. And then the same thing. Actually, we'll just do JE jump. Make it easy. Yeah, okay. So other than that, I think they're the same. So here, instead of doing a jump, not we'll jump equals. Well, no, this would be a jump not equals. What? I'm confused. What? That would be a jump equals, according to the mnemonic. In this case, we're jumping. I suppose it's inverted because it's a test. Hmm. Then here we want to do it the other way around. So if it's not equal, then we want to jump to the end. Otherwise, we want to do everything. And before we do this, I'm also going to grab this to be while then address. Before we even do this, we want to just do a jump. Jump. Unconditional. Unconditional jump is E9. Have a jump. E, let's just grab that. It's the same thing again. And I think this will be the same thing again as well. It will just be E9. Okay. Hopefully. We'll find out. So here we'll just jump immediate, and this will be a jump back to the then, which we do want this then, I suppose, because we want the then address. Jump to. We want the relative address. And then actually, I suppose this would be here then. So there'll be two, I suppose. There'll be a while. EPA, W. Yeah. Once we just push two onto here. I mean, the while could be two things. Like that. Like that. Then we can have the const while begin, but while cond equal W written dot length. And then we can push this. I mean, that's a solution, I think. Then here we can say the const while cond address is that. Then we can jump to the while cond address. Yeah, because this is just an unconditional jump then, right? Just jumping to there. And then the then address stuff does actually need to be patched in, right? Yeah. Yeah, I think. How'd you say it? Huh? What? Files append. Oh, here. We're not doing this. Size. Oh, yeah. We need int cast. So if I say 0, while that is not equal to 4, then 1 plus. Not quite the output I'm looking for. I am actually looking for. I know we are writing an executable. Why is it not outputting anything then? So why it's not equal to 4, then because that's, yeah, so it's 1, so it's not actually doing anything, right? If I say equals, now it segbox. So yeah, well, so this should be the same. If GE, yeah, then that's an error. I don't know why I didn't. Who knows? Who knows? Anyway, let's look at the output without any of the editors. Anyway, so we move 1, we push that, we pop, then we duplicate, then we push 4, then we pop both of them, compare them, push the value, then yeah, and then we test, then we jump if they're equal to a while down. Only 87 bytes, supposedly. Yeah, too many. I don't know how it's being calculated. Hmm. Let's have a look in here. So yeah, we get the condition address. Then we write our condition, we test it, then we append the condition plus the end on. Then we structure our tuple. We have an unconditional jump to there, then to the address after the unconditional jump, we figure out the relative address and then patch that in. But we want to be jumping up, so I think this. I think this needs to be the other way around then, doesn't it? Hmm. Because it should be this all underflow. Yeah. So we'd have to cast both of these as I32. As I32. That work? Maybe. Actually, no, we don't need to do that, do we? We figure this out, but we then do the negative. I don't know if we can do the negative here because I think that wants. Let's try running this. So this way it's not jumping forward, but it's jumping. Seg volts. Oh, and that's a point is signed. We're up on that 3-hour mark. I don't see what's going wrong here. So we grab where we are. We need to patch. Patched a bit needs to be patched. And then we unconditionally jump. And we make sure that this address is the address that we want to jump to in the patch is after our unconditional, which is correct. Otherwise, we'd just be sitting there looping the whole. Hmm. I think negating one here is going to. I think it does now. Yeah, and we want to. And it's an I-32 still. Mm-hmm. I can't see it. I am lost. Let's. I mean, I would open up in a debugger, but obviously we don't have any help there, and I just knocked the microphone. No, I'm lost. What is going on with this? I'm just sitting here looking at it, but I'm not making sense of what the issue is. Probably something stupidly simple as well. Okay, what I'm going to do is I am going to leave this in its current state. We got the ifs working again and everything like that. It's just the loops, so we didn't actually get around to fixing the loops yet, I suppose, which is the goal for today, but we didn't do it. But we do have a much nicer system for doing everything else, so I can get rid of this now. All of this old code. Bye, and there we go. We have a much nicer set of nodes and ways of patching things and such. So it should be a lot easier to make things work with once we get these loops working properly. But I'm going to give up on it for today, and whether I do a stream tomorrow or not, we'll try and get it fixed then. Obviously, some fresh eyes will probably help quite a bit, and we'll get it fixed in no time. But until that point, I think that'll be all. Unless... Ah. Well, I figured out one thing already as well. I want to append our whiles here with the while cond address and say undefined here. And then once we get to here, we want to get the whiles. So we want the items. You'll be back. I'll have fun. Might have a solution. Yes, whiles.items.len1. We want to set that to be this. Because we do want this before the condition, so we need to know where the while is at this point. And then we can do the condition again, then pop, test, jump, so on and so forth. Still not correct, but this was incorrect anyway. I suppose I'll call this just the actual while address itself, because where the while is. Mm-hmm. Then we jump here, this jumps to that while address. And then it reruns the condition. Because, you know, after the stuff will be the condition, then we can do the test. But yeah, I'm still not sure why this isn't working. This should be working, so I do not know why it's not. Obviously, as I said, probably something stupid. It's normally something stupid. So we'll see. We'll see tomorrow. Or whenever the next stream is. Not the best ending, but we'll figure it out. Anyway, enjoy. Hope everyone has enjoyed their time watching this. And we'll crack on.